So we'll start with the observation of a block sliding down a ramp at constant velocity. Therefore, the forces are balanced. You already know how to do an interaction diagram and a free body diagram. So we'll go ahead and sketch. Please note this is a sketch of a force vector addition diagram. I want to get an idea of what it should look like when I measure the angles and I measure the lengths of the forces. This is closed, therefore we have balanced forces. The next step is to come up with a scale. I'm going to go ahead and choose 30 newtons is 9 centimeters. So I'll use my gravity as my down for 9 centimeters to represent that 30 newtons. I use a straight edge and a ruler to measure that, and my gravity on block by earth is 30 newtons. I'll then measure an angle. This is where students sometimes have a tough time. Take my protractor and line up the 0 right at the tip, and then I'll go ahead and measure out 32 degrees. There's 10, 20, 32. And then I'll go ahead and draw a dotted line so I know the direction of the force. And from my sketch, I know the normal force goes off in that direction. Next, I'll go ahead and measure the complement of that, which will be 58. Again, I'll line up my protractor so my 0 line is at the other tip. And then I'll go ahead and start at 0 and count my way over. 10, there we go, 10, 20, 30, 40, 50, 55, 56, 57, 58 degrees. And I'll draw another dotted line. And I know that that will represent the direction of my friction force, which is perpendicular to my normal. Just quickly label that 58 degrees. Next step is to go ahead and close this off just like my sketch. My sketch showed balanced forces. Therefore, I will have a triangle that does not have any gaps in it. There's one side, and here is the other side. I'll go ahead and label this with my arrows, or the head of my vectors, to show the direction of the forces. We'll start measuring these, and this one I measure out to be, looks like 7.4 centimeters, which for my scale, well, actually let me measure this other one. The other one is 4.7 centimeters. I'll use my scale to determine the forces. This one, friction on box by ramp, is worth 16 newtons, and the normal on box by ramp is worth 25 newtons. I can always check this with Pythagorean theorem also, and 881 is approximately 900. Even the square roots are pretty close.